Right. Sound check, everybody. Good evening, everybody. Can you all hear me? Is it loud and clear? Right. Sound check, everybody. Good evening, everybody. Can you all hear me? Loud and clear? Loud and clear, no? Arif. Right. Sound check, everybody. Good evening, everybody. Can you all hear me? Loud and clear? Right. Good evening, everybody. This is week 5, day number 3. Welcome to another edition of Final Countdown. I hope you have done the 2004 paper, the third day paper. So today we'll be completing 20 MCQs, 1 structured, 1 essay. Right. We'll start off with the work. First one is a statement question. Right. Consider the following statements made regarding the voltmeter and ammeter. So we are talking about the voltmeter and the ammeter in a circuit. Voltmeter and ammeter in a circuit. Right. A negative terminal of the ammeter and the positive terminal of the voltage should be connected together for proper operation. Negative terminal and positive terminal should be connected. Right. Let's see. So here positive, negative terminal, here positive, negative. Positive, negative. So I think here positive, here negative, right? So I think the connection is correct, no? Connection is correct. Yeah, connection there is correct. Statement A is correct. Internal resistance of a voltmeter should have a value lower than R for proper operation. Actually, internal resistance should be infinite. If the resistance is small there, clear? That means there is an effective resistance here. Current will go through the voltmeter and the voltage across the effective resistance is given. Okay. Now terminal potential difference we have done. We have done potential divider method. All of you know this. So what happens is when the current divides, if the current divides, we are finding the voltage across the effective resistance. But to get the actual voltage, if the resistance is very large, if the resistance is infinite, then the current will not go across the voltmeter. Current is not going across the voltmeter means correct reading can be given. So this statement is wrong. Write a sentence there. Write a sentence there. For proper operation, the resistance across the voltmeter must be infinite. The resistance across the voltmeter must be infinite. The resistance across the voltmeter must be infinite. But if the voltmeter has a resistance, but if the voltmeter has a small resistance, it will read the voltage across the effective resistance. It will read the voltage across the effective resistance. Okay. So statement B is wrong. If A and B are interchanged by mistake, the ammeter is now expected to read a smaller current than the reading obtained. Right. So if you by mistake put a voltmeter here, voltmeter resistance is very large. Very large means current in the circuit will be small. Current in the circuit will be small. So ammeter will read a smaller current. The statement C is also correct. A and C is correct. A and C is correct. Answer number 4. A and C is correct. Answer number 4. Right, no? Right there. If we connect a voltmeter in series, the effective resistance will be very large. The effective resistance will be very large. Therefore, the current through the circuit will be small and ammeter reading will be small. Right, no? So clearly I have told you those points you must remember. Okay? Those points you must remember. Right. In the circuit shown, the bulb operates at a given rated value. Internal resistance of the cell is negligible. The value of R is. What's the rate? 24 watt, 12 volt. So when they give the power is equal to VI. This is for the bulb. Power is given here. Power is given 24 watt, 12 volt. We can find the current. Current is going to be 2 amperes. So current through the circuit here is going to be 2 amperes. Now apply Kirchhoff law. If you apply Kirchhoff law, sum of EMF equals sum of potential differences. Sum of EMF minus 2 plus positive. Loop direction, current direction same. 2 times R plus voltage here is 12. 12 equals to R. R is equal to 6 ohm. 6 ohm means correct answer is answer number 3. Correct answer is answer number 3. Okay. Correct answer is answer number 3. So operating means it's working at 24 watt, 12 volt. So from there you can find the current. From the current you can do the required calculation. Okay. From the current you can do the required calculation. Right. Two wires of equal cross section but having lengths L and 2L and resistivity ρ1 ρ2 respectively are connected end to end to form a composite wire as shown in the figure. The effective resistivity of the composite wire is, right? So effective resistivity. So here R is equal to ρ1 L over A. R2 is equal to ρ2 2L over A. Now resistors are connected in series here. So effective resistance is equal to R1 plus R2. Effective we can say ρ equivalent. Well, length is going to be 3L. Length is going to be 3L. Area is A. ρ1 L over A. ρ2 2L over A. All the A's cancel off. All the L's cancel off. Equivalent is ρ1 plus 2ρ2 divided by 3. ρ1 plus 2ρ2 divided by 3. Correct answer is answer number 5. Correct answer is answer number 5. Correct answer number 5. Okay, right. Look at this carefully. Right. When an object O is kept in front of a thick plane mirror formed by silvering one side of a thick glass plate as shown in the figure, a series of images I1, I2, I3 can be observed. Which of the following statement is correct? Now what is happening is, here refraction or reflection, reflected rays forming images here. Here reflected ray extended form images there. Here there is another reflection form images there. What can you say? Many reflections occur here inside. The intensity of light will increase or reduce. When many reflections take place, intensity of light will reduce. So the brightness of the images will continue to reduce. Clear? I1 is the brightest and the intensities I2, I3 will decrease gradually. Clear? They will start decreasing gradually. Okay, no? Next one. I2 is the brightest and the intensity of I3, I4 decrease gradually. Right. So what's the difference between 1 and 2? If you look at this carefully, here the location of I1 is very important. I1 occurs on the silvered surface. Here I1 occurs on the silvered surface. So normally what happens is, some will reflect, some will refract. Okay. So what you will see is, you will see the images beyond the glass, no? Beyond the glass. So what you are seeing, let's say you keep your eye here, what you see is, you don't see this, you see the image behind this, somewhere here. So I2 will be the brightest one, then gradually I3, I4, I5 will start reducing. Here, I3, I4, R5 will start reducing. Normally what happens is, when you have a thick glass, around 80% of the light rays will refract, 20% will reflect. So this is occurring due to reflection. That's important. 80%, around 80% refract, 20% reflect. So this occurs due to reflection. So the intensity of this light is actually less. Refraction 80%. First refraction is here. First refraction is here. So here refraction, some will refract. Here refraction here. Here reflection 80%. So 80% there. Out of that 20% is reflecting here. Whatever is coming back. So here only you will see the first image. I2 will be the brightest and then the intensity will reduce. Right there. Generally when a light ray travels from a medium, when light rays travel from a medium, 80% of the light rays will refract. 80% of the light rays will refract. While 20% of the light rays will reflect. Now some of you are going to see this calculation wise. Okay. I is here, 20% reflecting 0.2, 0.8 is going inside, 80%. 80% is going inside. 80% is going inside, hits here, comes out. Out of that 80% refracts means 0.8 I times 0.8 square. Out of this 0.8 times 0.2 I will reflect. So you can see this intensity is less, this intensity is more. 0.8 square means 0.64 I intensity. This intensity is going to be 0.2 I. This one coming out from here, how much? 0.8, 0.2 is 0.16. 0.16 times 80. 0.16 times 0.8 is going to be how much? 0.128. So 0.6, 0.128. Clear? So here what happens is it keeps on reducing. So here if you check and see, 0.8 times 0.2 I times 0.8. From this you will get 0.0128 I. So intensity keeps on reducing. So here the intensity of light that you will see, image you will see is 0.64 I. Here it's going to be 0.0128 I. Here 20% will reflect. So whatever is coming here, 0.2, 0.2, 0.16. 0.16, 0.2, 0.032. 0.032, 80%. 0.0256 I. So you can see intensity of light will keep on reducing. This intensity here is 0.2 I. So which is bigger? This is bigger. So brightest image is the second image. Brightest image is the second image. If you want, you can write it down. So I is coming, 0.2 will reflect, or 20% will reflect, 80% goes, 80% comes, 80% will refract, 20% will reflect out of this. Here comes here, 80% will refract, 20% will reflect. Which I can see, brightest image is here I2. Brightest image is there I2. Okay, clear? Right. Consider the following statements made regarding the charge distribution shown. Charge distribution shown. Right. A. No electric field lines cross the closed surface S1. No electric field lines cross the surface S1. Is that true or false? False. From the positive charge, field lines will go out. For the negative charge, field lines will come in. The net flux is 0. That means what? Number of positive charges going in equals number of negative charges coming on, field lines coming out. So this statement is wrong. What you can say is number of field lines going in, number of field lines moving in equals number of field lines moving out. Number of field lines moving out. Statement A. Flux is 0. Flux is 0. Right there. Okay. Second one. Total electric flux due to charge plus 3q does not depend on the rest of the charges present. Right, look at the board carefully. If I take a Gaussian surface around plus 3q, let's say S3, the flux through S3 depends only on the charge 3q. There. So this statement is correct. So if you take a flux there, flux through surface S3 is how much? 3q divided by epsilon naught. Correct? Does not depend on the surrounding charges. Statement B is correct. Statement B is correct. Part C. Net electric flux through the closed surface S2 is not 0. If I take surface S2, sum of charges through surface S2, sum of charges if I take, how much? Minus 3q minus q plus 3q plus 2q, 2q, 4q minus 4q over epsilon naught minus 3q plus 3q, 4q cancel off, minus q over epsilon naught. Net flux is not 0, correct. B and C correct. B and C correct. B and C correct. Okay, no? B and C correct. Right. Moving on. Okay. Two cubes A and B. Two cubes A and B. Same geometrical dimension floating water as shown in the figure. Cube A has half the volume above, whereas cube B has quarter of the volume above water. Quarter of the volume above water. If cube B is carefully placed in cube A, on cube A, which of the following indicates the correct statement? Look at the board now. Now, generally, sum of forces acting upward should balance sum of forces acting downwards, no? Right, no? Floating, no? Upward forces should balance downward forces. If I consider A upward forces, half the volume above means half the volume below. V over 2 rho Wg, that is equal to mass of A. Same way, quarter of the volume above means 3/4 below. Identical dimensions, same volume. Rho Wg, Mbg. Now, if you keep A on top of B, let's mathematically add this in. Ma plus Mbg. Ma plus Mbg. If you simplify it, half plus 3/4 V rho Wg. Now you all know this bit. You all know this bit. If you take a beaker, if you keep B on top of A, what will happen? Half and 3/4 means what? 1/4. 1/4 is 5 over 4 V rho Wg. That means if I simplify this, this is what you will get. 1 plus quarter V rho Wg Ma plus Mbg. 1/4 means B is completely submerged. Sorry, A is completely submerged. Quarter volume of B is underneath. Full volume there is underneath. So 1 means A is completely under, quarter of B is also under. So A is completely submerged. Correct answer is answer number 3. Correct answer is answer number 3. You can see 3 steps, you get the answer. No need to endorse too much. Clear? Easily you can get the answer there. Clear? Easily you can get the answer. Right. A particle P moving with a uniform velocity 4 along the x-axis passes the origin at time t equal naught. So particle P moving with uniform velocity 4, here t equals naught. There. A second particle Q moves along the same direction in uniform 5, passes origin O after 1 second. After 1 second means P has already gone. If I draw this back again, t equals 1 second. Q is passing here with 5 meter per second. In 1 second, P has already traveled. In 1 second, P has already traveled how many meters? Basic, no? 4 meters per second means gone 4 meters, right? Particle Q will reach the particle P when they have traveled a distance, right? Now, when will overtaking take place? Overtaking take place. So, overtaking occurs means now we can use some relative motion knowledge. What is relative motion? Velocity of Q with respect to P. Velocity of Q with respect to P means mathematically we are stopping this. With respect to P means mathematically we are stopping it. How do you mathematically stop? Put an equal velocity in the opposite direction. Here also equal velocity will add in the opposite direction. So here this is at rest. Here the velocity is 1, gap is 4. Here velocity is equal to 1 meter per second in the forward direction. 1 meter per second in the forward direction. Okay. Observe this carefully. So, time take to overtake. Time taken to overtake P. So, distance 4 seconds. 4 seconds. Right. Question is very simple. When overtaking occurs, how far they have traveled? So 4 more seconds. 4 more seconds here. Here t equal 1 has already gone. 4 more seconds. So altogether 5 seconds have gone. For Q 4 seconds. For Q 4 seconds. For P already 5 seconds. So distance travel. Distance travel. If you take 4 times 5, 20. If you take 5 times 4. 4 distance traveled by Q. 4 seconds, 5 meters per second. What's the distance traveled? 20 meters. 20 meters from the origin. 20 meters from the origin. Using relative motion, you can easily find this. Remember, whenever you are talking about overtaking problem, back one has to overtake the front one. Mathematically stop the front one. Mathematically, how do you stop the front one? Velocity of Q with respect to P. With respect to P means P is mathematically at rest. When we say Q with respect to Earth, we are assuming the Earth is at rest. Same way, Q mathematically, P is at rest. From there we can find the time taken by Q. Time taken by Q is 4 seconds, or 4 times 5 actual velocity. Distance traveled from the origin is 20 meters. Okay, no? Distance traveled by the origin is 20 meters. Okay. Right. Moving forward. Okay. Let's work. Intensity of sound emitted from a point source is inversely proportional to the square of the distance from the source. Intensity is proportional to square of the distance from the source. I proportional to R square. I proportional to R square. Okay. I proportional to R square. What are they asking? If the intensity level of sound at a distance of 1 meter from the point source, intensity level, that means beta, don't forget, is 50 decibels. The sound intensity level at a distance of 10 meters. So, right, be a bit careful. I1 at a distance of 1 meter. Next is at a distance of 10 meters. So beta 1 is 10 log I1 over IO. Intensity at 1 meter is level is 50 decibel. 10 log I1 over IO reference intensity. Now I'll apply for the second case, beta 2, 10 log I2 over IO, equation number 2. So what will happen here is lesser R, larger I, 1 minus 2. 50 minus beta 2, log subtraction is log division. Log subtraction is log division. So 50 minus beta 2, 10 common. Log subtraction means log division. I1 over I0, I2 over I0 inside brackets here. Here 50 minus beta 2, 10 log I1 over I2. What is I1 over I2? If I take I1 over I2 here, ratio is going to be 100. So I1 over I2 is 100, 10 log 100. 100 is 2, 20 here, 50 minus beta 2. What is beta 2? From this you realize beta 2 is equal to 30 decibel. Beta 2 is equal to 30 decibel, answer number 4. Beta 2 is equal to 30 decibel, answer number 4. There you go. Once you need it, write it down. Once you need it, write it down. Write down carefully. Right? Okay. Moving on. Carefully look. Figure shows a digital circuit. You call these almost very basic NAND gate or gate. NAND gate or gate. Variation of the inputs are given 0, 1, 0, 0, 1, 1, 0, 1, 0. You call this timing circuits, timing diagrams. We call this timing diagrams. Output X will be 0 in which time interval? Let's see. Here A is 0, B is 0, C is 0. Right, let's see. 0, 0 should be AND gate 0, NAND gate should be 1. Here 0, 0, AND gate should be 0, NAND gate should be 1. 1, 1 means output is 1. Right. Next one. 1, 1, 1. 1, 1, 1. 1, 1 AND gate should be 1, 0. 1, 1 AND gate should be 1, here 0. 0, 0 will be 0. There you have 0. So T1 to T2 guaranteed. T1 to T2 guaranteed. I don't know whether we need to continue calculating. Ninth one directly the answer is answer number 2. Clear? Ninth one directly answer is answer number 2. Right? If you want, maybe go one more step. 0, 1, 0. 0, 1, 0. 0, 1 and gate 0, here 1. 1, 0, 1. 1, 1 means 1. So 0 occurs only here. T1 and T2. Correct answer, answer number 2. Correct answer, answer number 2. Right, moving forward. Moving forward. Right. Technical electronic is my favorite, so yeah, here we go. First of all, you must decide what kind of circuit is this. Is it an open loop circuit or a closed loop circuit? You can see the output is connected to the input, so it's a closed loop circuit. Closed loop circuit. So closed loop circuit means you use closed loop equations. Right. That means golden rule number 1, golden rule number 2 will come into play. Right. Here supply voltage are there, so whatever happens, output can never be greater than the supply. Okay, no? Right. So here plus 2 volt. V plus is going to be, non-inverting input is going to be plus 2 volts. Can currents go into op-amp input? No. Golden rule number 2. There is no current inputs. Input resistance is infinite. Output resistance is negligible. So output resistance can take, current can occur. Input current can never take place. Right. Next one. Careful look. Here output voltage, open terminal. So current can travel from high potential to low potential. Current can travel from high potential to low potential. We will call that V minus. We call that V minus. So technically, if you look at this branch here, I can write it like this. Grounded 1 kilo ohm, 10 kilo ohm. Voltage here is V minus. Here voltage is output. You are done. Potential divider theory. So what's the voltage there? V minus. V minus is resistance into total voltage. 1 kilo ohm into total voltage divided by the addition. 10 plus 1. So output voltage divided by 11 is V minus. Output voltage divided by 11. Right. Have a look. Now V plus is given, V minus is given. Output voltage is what we have to find. Output voltage we have to find. Remember, output voltage is less than or equal to plus or minus 10. Output voltage can never exceed the supply. Output voltage can never exceed the supply. Here, output voltage can never exceed the supply. Look at this. So V minus here. From this we can say golden rule number 1. V plus equal V minus, closed loop circuit. V plus is 2 volt. Output divided by 11 plus multiply. V output mathematically plus 22 volts. This is not possible. This is not possible. If it's not possible, it can never exceed the supply. This is the condition. Therefore, output voltage here plus no. Maximum possible is plus 10 volts. Correct answer is answer number 4. Correct answer, answer number 4. Again look. V plus is 2 volt. V minus potential divide I found. Golden rule number 1, V plus equal V minus. That means 2 volt. I'll write it here. Right, V plus equal V minus, 2 volt equal V output over cross multiply. Output is plus 22. Output is always less than or equal to the supply. Here positive means positive supply. So answer is answer number 4. Right there. This is a closed loop circuit. This is a closed loop circuit. Therefore, we must apply closed loop rules. We must apply closed loop rules. Right now. So this is the order. Find V plus, find V minus, golden rule 1. From there you can get the output, but remember, your output can never exceed the supply, whatever happens. So output maximum possible will be plus or minus 10. Your output answer is plus 22, so output here will saturate at plus 10 voltage. So output will saturate at plus 10 volt. Output will saturate at plus 10 volt. Okay. Right. Moving on. The breakdown voltage of a Zener diode is 5 volts. That means after 5 volts, current will start passing through it. Internal resistance of the cell is negligible. When the value of R is changed from 25 to 0, current I in the circuit will. R is changed from 25 to 0. And looking at this carefully, you will realize like 10 volt here means 10 volt here. One shot, find the current. Find the current. So 10 divided by 100 means here 0.1 amperes. 10 divided by 100 means I can find the current there, I1 0.1. So what I have done is these kind of basic things directly find. Here 10 volt means here 10 volt. So 10 divided by 100 is 0.1. Right, okay, done. Now what? Look at the diagram carefully. Here resistance 25 means here 50. Here resistance 25 means here 50. There. So best is will start from resistance 0. If the resistance is 0, look carefully. Current will pass through this and the voltage is checked. Greater the voltage on top, lesser the voltage here. If this is 25, 50, 50 means this will divide. 5 volt, 5 volt. If this is 0, this is 50, this is 25, voltage here is more. Voltage here is more means voltage there is more. Understood? Here 25 means here on 50, here 50, voltage will divide equally. Voltage dividing equally means therefore that voltage there will be 5 volt, 5 volt. If the voltage here is 0, that means here 25 ohm. If the resistance is 0, 25 ohm, 50. Voltage will double. 2:1 ratio. So voltage will double means, what happens is 50 times 10 divided by the addition. From there you can get a bigger voltage there. right? So let's work this out carefully. When R is equal to 25, look at this carefully. If you want, let's ground this. This will be grounded anyway, 0 volt. Look at this carefully, look at this. Normally, negative terminal we can ground easily. Yeah? Negative terminal we can ground, so here there is no resistance. No? So here 0 volt means here also 0 volt, here also 0 volt, here also 0 volt. Look at the volt carefully. So if there is 25 ohm here 10 volt, here 10 volt, this branch. So here 10 volt is there, 25 ohm is anyway there. Here resistance is 25 ohm. Here resistance is 50 ohm. Diode is there. Without putting Zener, we'll just draw the diode. Reverse bias. Here 10 volt, here 0 volt, right? So here 50, here 50. What can you say? Here 50, here 50. 0 volt here, 10 volt there. 50 ohm here, 50 ohm there. Here you have diode. What can you say about the voltage? 5 volt, 5 volt. 5 volt is here. 5 volt will left. 5 volt will left. So 5 volt is breakdown voltage. There. 5 volt means breakdown voltage. Look at the voltage. Right. Then when R is equal to 0, when R is equal to 0, when R is equal to 0, I'll show this in a better way on the board easily. So here you have 25 there, 50 there, grounded here 0, 10 volts there, don't forget. 25 ohm, 50 ohm, diode. This you can simplify. Fifty ohm, 10 volt, equal resistance. Voltage will be 5 volt. 5 volt. 5 volt here means 5 volt there. Next situation, here 10 volt, 25 ohm is there, 50 ohm, diode is there. Here grounded 0. Okay. Now how will you find the voltage? 50 times total voltage divided by the addition. 50 plus 10. Voltage across the diode. 500 divided by 60. 500 divided by 60 you will get 8.3 volts. Around 8.3 volts. Right. Look at this carefully. Look at this carefully. Now here, once the voltage is more, breakdown has taken place. Current will pass through the least path of resistance. Current will go across this. Current will go through the least path of resistance. Current will go across this. Sorry, here mistake made. Here resistance is not 10, it's 25. So here correct it. $500 divided by 75, here 25, here 50. 25 times 3, 25 times 2, 0. 6.6 volt. Breakdown occurred, current will go like that. So what will be the voltage? What will be the voltage? Look at this. So here 25 ohm is there. 25 ohm is there. What can you say about this? Here you will get 50-50, 5 volt, 5 volt. So breakdown voltage 5 volt means here 5 volt is taking place. 5 volt there means 5 volt here. So the voltage difference there is 5 volt. Look at this carefully. Here 5 volt, 0 to 5. So 0 to plus 5. Plus 5 to 10. So potential difference there is 10. So let's find the current there. Potential difference is 10 minus 5. Current into total resistance 50. 5 divided by 50. Current there is equal to 0.1 amperes. What about this? Here voltage is 6.6. Voltage is 6.6. That means breakdown has taken place. Here, breakdown has taken place. Right. Now what has happened? Here if you take voltage 6.6, but don't forget, here breakdown voltage is 5 volt, beyond 5 volt nothing can take place. You know the characteristic of a diode. Here breakdown is 5 volt means 6.6 can't occur. 6.6 can't occur. So 5 volt. So 0 here 5. Potential difference there is 10 minus 5. I2 times 25. 5 I2 times 25. I2 is equal to 0.2 amperes. So your current will vary from 0.1 amperes to 0.2 amperes. Again look at the circuit. Here 25, 50. 50 means 5 volt, 5 volt. 5 volt, 5 volt means breakdown has taken place. Breakdown has taken place. So voltage across the diode is 5 volt. Right, done. So voltage here 5 volt means 0 to 5. This is going to be 5. The voltage difference here is 5. Resistance is 50. 5 divided by 50. Current you can find. What about here? Now here if you take voltage is 6.6. But 6.6 can't occur. So here what? 5 volt. So here also 5 volt, across this also current will go. If you want, you can divide and quickly get the answer. There. But current will pass through the least path of resistance. So no current here. Current will go through the least path of resistance. What about this one? Here just 5 volt means here current can pass through. If you look at it, 5 divided by 50, 0.1. 0.1 can go. Just break down. Here 5 volt. Current goes to the least path of resistance, so there you go, it goes. So here 5 volt means 10 minus 5, current I2 times resistance. Here current is 0.2. So current here is 0.1, current here is 0.2. Right there. The characteristic curve of a diode shows that once the breakdown voltage is released, once the breakdown voltage is achieved, current will flow through in the reverse bias condition through the diode. Current will flow through under the reverse bias condition through the diode. Even if the voltage is greater across a resistor, even if the voltage is greater across the 50 ohm resistor, even if the voltage is greater than 5 volts across the 50 ohm resistor, breakdown voltage will occur across the diode. Breakdown voltage will occur across the diode. Right? No? So until breakdown is achieved, if breakdown is not achieved, current will go through resistor. But once breakdown is achieved, current will go through the diode. Is it clear? You can put in the chat. Is it clear? Okay, no? So when you solve the resistor circuits, you will know all of this. Always be aware, once breakdown is achieved, now here the voltage potential divided is 6.6. So don't think here 6.6. 6.6 can never take place. Parallel means voltage same. 6.6 can never be achieved because 5 volt is already achieved. So only 5 volt can take place. Only 5 volt can. Right. Okay. So 0.1 to 0.2. 0.1 to 0.2, correct answer is answer number 4. Correct answer is answer number 4. Right. Question number 12. A metal sphere of radius r carrying a charge plus q is connected to a conducting wire of another metal sphere. A metal sphere of radius r carrying a charge plus q is connected by a wire to another sphere of radius 2r carrying another charge plus q. After connection, the amount of charge in the sphere of radius r is, right. So what is happening here? Here potential A, Q divided by 4 pi epsilon naught R. Here potential B, Q divided by 4 pi epsilon naught 2R. Denominator becomes larger means potential is less. VB is less than VA. Now when I connect this, from high potential to low potential, charges will travel until the potentials are equal. So if you take the spheres separately, A and B, if you take the spheres separately, A and B, yes, you can find the potential. Now once you connect, charges will travel until the potentials are equal. Charges will travel until the potentials are equal. So here you can say Q minus X divided by 4 pi epsilon naught simple r. Here you can say Q plus X divided by 4 pi epsilon naught 2r. Simplify this. Simplify this. 4 pi epsilon naught r, 4 pi r cancel off, cross multiply. 2q minus 2x equals q plus x. Simplify, q is equal to 3x. From this you can say x is equal to q divided by 3. They are asking what is the amount of charge remaining. Amount of charge in the sphere of radius r. So q minus q over 3, that's 2q over 3. 2q over 3 means correct answer is answer number 4. Correct answer is answer number 4. Right there. Charges travel from high potential to low potential. Charges travel from high potential to low potential until the potentials are equal. Until the potentials are equal. By equating the potentials at the end, we can find the charge moved. By equating the potentials at the end, we can find the charge that moved. Right. Okay, Biosava. Two long parallel thin wires placed at a distance d apart is shown in the figure. Carrying equal currents I. Currents are in the same direction means Biosava theorem. What can you say? Currents are in the same direction means there will be attractive force. In other words, we talk about the magnetic field. Here current magnetic field is inverse. Magnetic field is inverse due to P. Here current magnetic field is outwards. Magnetic field outwards due to Q. So magnetic field P inwards, Q outwards, they will cancel off. Somewhere in the middle the resultant can be 0. Right? Resultant can be 0. So this is wrong, this is wrong, this is wrong. One of these two. Don't forget B is inversely proportional to R. So it can't be a straight line. Correct answer is answer number 2. Right there. When currents are traveling in the same direction, the magnetic field at the centers can be 0. The magnetic field at the center can be 0. By applying the right hand rule, we can find this. By applying the right hand rule, we can find this. And since B is inversely proportional to R, we can find the variation to be non-linear. The variation to be non-linear. Okay. Right. Right, have a look. Next one. Two spheres, each of radius a but different masses m1, m2, move down at their terminal velocities in a liquid of viscosity eta at the instant shown in the figure, right? The separation x between them, right? Let's assume that they have achieved terminal velocity. So terminal velocity for v1 is 2/9 eta, same radius a square g, same radius, different masses because densities are different, rho 1 minus rho w, or rho 1 minus rho l, liquid no, rho 1 minus rho l, okay. What about v2? 2/9 eta a square g, rho 2 minus rho l. M1 is larger than M2, it's larger the mass, greater the density. So V1 has a greater terminal velocity. M1 is larger than M2 means rho 1 is larger than rho 2. Now you might wonder how to get this, the bio students. Very simple logic. Look at this. Mass is volume into density. Same volume into density. So rho 1 is larger than rho 2. Right. Larger density, larger difference, larger velocity. Smaller density, smaller difference, smaller velocity. Therefore, rho 1 minus rho l is greater than rho 2 minus rho l. Larger change means V1 is larger than V2. So these conclusions quickly you should be able to make. Terminal velocity is found. One mass is great. Rho 1 minus rho 2. This combination here, and V1 is larger than V2. Right. What are they showing? Separation. Now this velocity is greater. This velocity is V1. This velocity is V2. What will happen to the separation? Separation will increase or reduce. Common sense, reduce. Separation will reduce. Okay. So how are you going to find this? How will you find the separation? There. How will you find the separation? Right. Look at this carefully. So go back to the board. Look at the board now. Terminal velocity of m1, terminal velocity of m2, separation is x, clear? So we can say velocity of m1 with respect to m2, that is v1 minus v2. Look at the board. v1 is 2/9 eta a square g, rho 1 minus rho l minus 2/9 eta a squared over g, rho 1 minus rho 2 minus rho l. If you carefully open brackets, you will get 2/9 eta a squared g, rho 1 minus rho 2. Here minus rho l minus plus rho l will cancel out. So velocity of m1 with respect to m2. I am slowing this down. From this, what can you say? Rho 1 minus rho 2 has come. So separation will reduce. So if I fold this down a bit slightly, per second. So separation per second means they are giving a velocity actually. Right, let's get back to it. Okay. So here separation will start reducing per unit time. So 2 over 9 eta A square G. What is density? Mass over volume 4 over 3 pi A cube. Here M2 4 over 3 pi A cube. Simplify this carefully. Simplify this carefully. Here velocity of M1 with respect to M2. 2 over 9 eta A square G here. 3 goes on top, 3 take it out. 4 pi A cube. 4 pi A cube M1 minus M2. 4 pi A cube M1 minus M2. Simplify the relationship. 2, 3 times 1, 3. 2 G 12 pi eta A. 12 pi eta A. 12 pi eta A. Actually it's 6. M1 minus M2. Simplify this further. G 6 pi eta A. M1 minus M2. So distance will decrease. Right. So G over 6 pi eta. G over 6 pi eta. G over 6 pi eta. 6 pi eta is there, M1 plus M2 is there, M1 minus M2 is there. From this you can easily see that M1 minus M2 is there in two locations, here and here. Here increasing, here decreasing. So simple answer, directly find 5. Directly you can find the answer 5. Clear? Directly you can find the answer 5. But let's say somebody wants to get in these terms, 6 pi eta. 6 pi eta. Right? So go back to your work. M1 minus M2G, right? Now 6 pi eta A. 6 pi eta A. So directly the answer is come. So the distance will decrease per second with this. Directly answer is there. Okay, no? 6 pi eta B. Answer is answer 5. Right there. Right there. Terminal velocity of V1 is larger than V2, so distance will decrease. Terminal velocity of V1 is larger than V2, so distance will decrease. Okay, no? Right. Moving up. This is a good question. The mean temperature theta and the dew point T atmosphere 6 am to 8 am in 10 consecutive days are shown. So consider the following statements. Consider following statements. So what have they given you? They have given you that cross is theta. Cross is theta. Look at this. Cross is theta. Dot is temperature. Dot is temperature, right? Look at the board carefully. So mean temperature and the dew point temperature. Mean temperature is somewhere here. Dew point temperature is low. Dew point temperature is low. Day number 1. Next. Mean temperature there, dew point is increasing. Dew point is increasing. Dew point is increasing. Somewhere here mean temperature and dew point both are equal. Mean temperature and dew point both are equal means what can you say? Saturation takes place. Saturation occurs. So at the mean temperature the water vapor in the atmosphere equals to the dew point. So saturation will occur. So that's very simple and direct. That's very simple and direct. Relative humidity is maximum on day number 9. Here, what can you say? Here, dew point temperature is low, mean temperature is high. High mean temperature means more water vapor can be kept. More water vapor can be kept means it will, to reduce it, more water vapor can be kept. So mean temperature is not equal to dew point temperature. Saturation does not take place. Saturation means the temperature at which the existing water vapor saturates. Relative humidity is maximum on day 9. Relative humidity is maximum on day 9. What's happening? Day 9, dew point temperature and mean temperature both are different. Large gap. Atmosphere temperature is very high. Dew point temperature is very low. Clear? Dew point temperature is very low. Very high atmosphere, very low atmosphere. So unsaturated vapor. Day 6 has more water vapor in the atmosphere than day 8. Day 6. Look at day 6. Use a different color. Day 6 is here. Than day 8. What can you say here? Little by little, mean temperature is close to dew. Mean temperature is close to dew means little by little the water vapor content is large. Temperature is more than dew means the difference is large. That means the amount of water vapor in the atmosphere is low. Clear? Amount of water vapor in the atmosphere is low. So therefore you can say this is correct. Day 6 has more water vapor. Closer the temperature is to dew point, almost saturation is taking place. Almost saturation is taking place means more water vapor in the atmosphere. Mist is possible in none of the days. Mist is possible in none of the days. So saturation takes place here. Mist is possible. Mist is possible there. So this is wrong. Only correct statement is B, answer number 1. Right there. When the mean temperature and the dew point temperature difference is very large. When the mean temperature and dew point temperature difference is very large, that means it is an unsaturated vapor. That means it is a unsaturated vapor. Unsaturated vapor. The closer the mean temperature reaches the dew point temperature, water vapor in the atmosphere will increase. The closer the mean temperature reaches dew point temperature, water vapor in the atmosphere will increase. Water vapor in the atmosphere will increase. Water vapor in the atmosphere will increase. Is it clear? Understood? The closer this gets, the more and more, now saturation is almost going to take place. More and more water vapor is in the atmosphere. Okay? Right there. On the 5th day, mean temperature is equal to dew point temperature. On the 5th day, mean temperature is equal to dew point temperature. Therefore, we can easily say that saturation will take place on day number 5. Saturation will take place on day number 5. Saturation will take place on day number 5. Right. Okay. Mass m1 of ice at 0 degree Celsius is added to mass nW of water at room temperature of 30 degree Celsius. and the mixture is stirred until ice is completely dissolved. Mixture is stirred until ice is completely dissolved. Ice is what? Completely dissolved. If the minimum temperature of the mixture is found to be 10 degrees Celsius, if the minimum temperature of the mixture is found to be 10 degrees Celsius, look at the board, to be 10 degrees Celsius, the amount of heat absorbed by the mixture from the container and the environment is, look at the board carefully, mass M1 of ice at 0 degrees Celsius is added to mass water MW, mass water MW at room temperature 30 degrees Celsius, and the mixture is stirred until ice is completely dissolved in water. Ice is completely dissolved in water means dissolution completely takes place. If the minimum temperature of the mixture is found to be 10 degrees, so minimum here is 10, ice water mixture, the amount of heat absorbed by the mixture from the container and the environment is, right. Look at this carefully. Heat given equal heat absorbed. Heat given equals heat absorbed. The heat absorbed by the mixture from the container and the environment, right. Who is giving heat? Water is giving heat. MW, SW 30 minus 10. Environment is giving X. Environment is giving X amount of heat. That is also absorbed to melt the ice. That is also absorbed to melt the ice. Mass of ice. What is happening? Mass of ice will completely melt LF. And that mass will reach 10 degrees Celsius. So amount of heat absorbed from the environment and the container, MIL plus M1 CW or SW 10 minus MW SW 20. This is your answer. M1L plus M1 SW10, M1 SW10 minus 20 MW SW. Correct answer is answer number 2. Correct answer is answer number 2. Right. So you can see heat given absorbed or heat given by the environment and the container take as X. X can be found. Right. Okay, no? Two small objects of equal masses are attached to each other by a light string BC. Light string is BC. And this system is connected to a fixed point A with another light string AB, as shown. The masses are then made to move in a horizontal circular path of radius R and 2r with the same angular speed so that points A, B, C are always in the same line. So here also same omega, here also same omega, right? Same omega. If T1 and T2 are the tensions of the string, what can you say? Right. Centripetal force equal mass into centripetal acting towards the center A. This on object B. Who is providing centripetal force? T2 minus T1 m omega squared. Radius here is going to be capital R. Same omega. Then apply centripetal force equal mass into centripetal acceleration to the center A on object C. Who is providing centripetal? T1 mass m omega squared. Radius is 2r. Here equation number 1. Here equation number 2. What can you say? Let me divide equation 1 by equation 2. If I divide equation 1 by equation 2, what will I get? T2 minus T1 divided by T1. T2 minus T1 divided by T1, that is equal to m omega squared r divided by m omega square 2r. There you go. M omega square 2r. From this, what can you say? From this, what can you say? M omega square RR cancel out. Cross multiply 2 times T2 minus 2 times T1, that is equal to T1. Here 2 times T2 equals 3T1. From this you can say the relationship. T2 is equal to 3 over 2 T1. 3 over 2 T1. Correct answer is answer number 4. Correct answer is answer number 4. Okay, no? Correct answer is answer number 4. Easily you can get. Right. Okay. Moving on. XY is a long vertical wire carrying a current I in the upward direction as shown in the figure. In the upward direction as shown in the figure. XY is a long vertical wire carrying a current I in the upward direction, right? Now if the current is going in that direction, right hand rule, magnetic field lines will be in concentric circles. Little by little the gaps will also increase. Here gaps are closer to increase, so increase intensity. Here currents are going, or the magnetic field lines are going in the anti-clockwise direction, right? ABCD is a horizontal plane directions of the magnet of the compass. What does the magnet give? Magnet gives you the tangent to the magnetic field line. These are magnetic field lines. Magnetic field lines. Magnetic field lines. So what does it give you? It gives you tangent. But be careful. The position which is directly near magnetic compass is same as the direction of the horizontal component. Alright, figure B. They are kept at locations P1, P2, P3 as shown in figure B. The position at which the direction indicated by the magnet of the compass is the same as the direction of the horizontal component of the Earth's magnetic field. Horizontal component of the Earth's magnetic field. Right. So, which location? So XY is a long vertical wire. Direction shown ABCD horizontal plane. Directions of the magnet of the compass are kept in positions P1, P2, P3, P4, P5. That is the plane ABCD of the wire, right? The position at which the direction indicated by the magnet of the compass is same as the direction of the horizontal component of the Earth is right. So which location is it parallel to the Earth's magnetic field? Now be careful. If you look at this, how the compass works. Look at the board. Now these are basic O-level work. Now magnetic field lines are coming in that direction. Look at the board. Because of this current, there will be a tangent. So it will indicate the tangential direction. Apart from this current, Earth's horizontal magnetic field also is there. So how many magnetic fields are acting? 2 magnetic fields are acting. So the compass will show the resultant direction of the magnetic field. Resultant direction of the magnetic field. Again look, because of this current there is going to be what? Tangential. Technically I will draw it here now. Only due to current or conductor. Only due to conductor, if you draw, it will be tangential in red also. Right. In red also. Okay. Right. Now Earth's horizontal magnetic field also is there. Earth's horizontal magnetic field is also there. Look at the board now. Earth's horizontal magnetic field, I'll mark like this. 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 Right. Now the compass will indicate the resultant direction. Resultant direction. Now here two magnetic fields, here resultant, correct? Here two magnetic fields, technically it should be along this direction. These two are parallel, it should be in the same direction. Then these two are perpendicular, it should be here. Here it should be somewhere there. Resultant is shown in yellow color. You don't understand this? Compass will indicate from the conductor along the tangent. So tangent drawn to an electric field line or magnetic field line will give direction, no? Same concept, no? So the direction of the magnetic field here is the tangent because of the conductor in red color. In blue color I have drawn the Earth's horizontal magnetic field. Earth's horizontal magnetic field. Earth's horizontal magnetic field. Horizontal magnetic field. Red color is what? Magnetic field, red color only due to conductor in red. Only due to conductor in red. Right. What is yellow? Yellow will give you resultant magnetic field. Resultant. Red and blue resultant is here. So these two resultant somewhere in between. These two resultant parallel. These two at an angle. Here at an angle. Here that way. So correct answer I can see is P2. P2 looks the one which is in the direction of the magnetic field. P2 is the one which is in the direction of the magnetic field. So wait, I need to erase and see this because of the diagram. Wait till I'll erase this and check and see. Here the indicated direction, both seem to be the same, or this looks a bit different. I think this looks the tangent, no? This looks the tangent. So here, so if it's parallel to the Earth's horizontal field, both are parallel. Both are parallel means same direction. Here it is slightly not parallel. Here slightly not parallel. You can see here the resultant is at an angle this way. Resultant is at an angle that way. So that's not the case. That's not the case. Right? So resultant at an angle, here tangent. Here resultant is at a tangent. Right. Resultant tangent means, what can you say? Earth's horizontal magnetic field is parallel to it. So right, what do you mean by parallel? What do you mean by parallel? Parallel is not this way, even though I have drawn it. Parallel is somewhere here. Parallel is somewhere here. So parallel is going to be this way. 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 Parallel magnetic field. Then what can you say about the tangent? So only circle tangent. 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 Right. Then what can you say about the resultant? Resultant is between these two, right? Resultant is between these two, right? All are in the same direction, resultant also same direction. Resultant in between these two, right? In between these two, right? Okay. So I think P3 is your correct answer. P3 is your correct answer. So you can erase this, you can mark P3. So horizontal magnetic field means here that way. So I hope you understood it. So the compass will give you the resultant magnetic field. The red color one is due to the conductor, the blue color one is due to the Earth's horizontal field. When both are parallel, it will be tangential. So tangential only here. So P3 is where both are parallel to each other. Others will give a resultant direction, resultant direction, resultant direction, resultant direction. Okay, that's right. As shown in the figure, the red color lines indicate the magnetic field due to the conductor. The red color lines indicate the magnetic field due to the conductor. The red color lines indicate the magnetic field due to the conductor. While the blue color line indicates direction of the Earth's horizontal magnetic field. While the blue color lines indicate the Earth's horizontal magnetic field. Blue color line indicates the Earth's horizontal magnetic field. The compass indicates the resultant direction of both the magnetic fields. The compass indicates the resultant direction of both magnetic fields. The compass indicates the resultant direction of both magnetic fields. Both magnetic fields. If both are parallel to each other, if both the magnetic fields are parallel to each other, it will remain along the tangent continuously. It will remain along the tangent continuously. And this is achieved only in P3. And this is achieved only in P3. And this is achieved only in P3. Okay? Right. Okay. Moving on. Okay. Question number 19. A 1 meter long cylindrical copper wire is accurately calibrated when in a horizontal position. In two separate occasions, the rod is kept in the vertical position by placing on a horizontal platform and by hanging from a ceiling. So one you are keeping, one you are hanging. Okay. The distance between two consecutive millimeter marks, delta L, and the variation of delta L along the rod in both occasions is best represented by, look at the road carefully. Here the rod has a weight, here there will be reaction acting. Here it's being pulled. Here weight is acting downwards. So here technically the rod is compressed. Here the rod is compressed. Here the rod is what? Extended. Two different ideas. Huh? Two different ideas. Okay. So Young's modulus is stress over strain, force over area, delta L over initial L. Cross multiply, delta L is equal to FL over A Young's modulus. FL over A Young's modulus. Right. So your graph is given between what? Delta L and along the rod, along L. Right. Here delta L, FA Young's modulus L, y is equal to mx. What can you say? What can you say? So here, one moment there is a compression, one moment there is an extension. So extension means logically the length here should increase. Here compression means it should reduce. So straight line variations, A is going to be reducing, B is going to be increasing. It can't be the same. Clear? So look at this carefully. Right. So not changing, you can remove. Both are reducing, you can remove. Both cannot reduce. Both cannot reduce. So A is reducing, B is increasing. B is reducing, A is increasing. Think carefully. So your selection will be between 2 and 5. 2 and 5. But also you must think with this will never take place. Of course, these two for sure no. Can the reading or delta L be negative? Let's see. 1 meter long wire, X is here, X is on top, Y is at the bottom. X is at top, Y is at the bottom. Right. The rod is kept in the vertical position by placing a horizontal platform. The distance between two consecutive millimeter marks, what will happen? Right. Here, as you keep coming down, the load increases. If I am logically thinking this, you can break this into small masses. I am putting more weight on top of each other. When I put more weight on top of each other, what happens is, as I keep going downwards, the load increases so much, this will compress even more. Clear? It will compress even more. Right? So when I go from X to Y, the millimeter mark may pass and go to the negative side as well. We don't know. Clear? It might pass and go to the negative side as well. So this negative side is a real situation. The top one, nothing will happen. No? Top one, there is no compression. From the second one only compression will take place. Top one, there is no compression. Second one only compression will occur. Clear? So X no compression on A. These no. X no compression, so it's between 4 and 5. When I move down, Y compression can be negative as well. Go below. Here Y compression is positive. Wrong. Correct answer is 4. What about B? Well, B you are pulling from that direction. B you are pulling in that direction. So here the weight little by little, let's say you stack it. Little by little as you go down, force acting or pulling force will increase. The biggest tension is at the top, the smallest tension is at the bottom. So smaller tension at the bottom, smallest change. Largest tension, greater pull. So here largest tension. So if you look at this, largest expansion. So here bigger expansion, here small expansion. Here you have the biggest compression. Here biggest compression. Here you have smallest compression. Smallest compression. So very good logical question. Think about keeping a load on top of a load, top of a load, top of a load. Top one will have less compression, the top one. Next one, slightly. The more you go down, the bottom one only has greater compression. If I am pulling it, biggest tension is here. So biggest expansion is there. Smallest tension is here. Smallest expansion is there. So from this you can say, most suitable answer is answer number 4. Answer number 4, right there. As shown in the figure. As shown in the figure. As shown in the figure. The greatest compression occurs at the point Y in figure A. The greatest compression occurs at point Y in figure A. And the greatest tension occurs at point X in figure B. So the biggest change occurs at Y in A, biggest compression occurs in Y at A, and biggest extension occurs at X in B. Biggest extension occurs at X in B. Right? B only has the biggest, here's biggest. And the compression is so large, the division can move beyond the other division. The compression is so large, the division can move beyond the other division. Therefore, answers can be negative. Therefore, answers can be negative. Right. Okay. A closed rectangular wire loop falls vertically through two magnetic field regions. If viscous and upthrust forces on the loop are negligible, the velocity v time t graph of the loop is best represented by. Have a look here. Now when the loop enters, all of you know something important. To oppose it there will be a force upwards. To oppose it there will be a force upwards according to Fleming's right hand rule. So there will be a force upwards. When the loop is completely inwards, last time we had done, loop is completely inwards, force is 0, falling under gravity. Here falling down, acceleration less than gravity. Coming outwards, again there is a force. Falling down with acceleration less than gravity. Here falling in free space, falling under gravity. Just enters, falling with A. Completely inside, no change in flux, falling under gravity. Slightly coming out, falling under simple A. Completely coming out, falling under gravity. This is less than G. This is also less than G. Interesting. First one falling under gravity. Then gradually it will reduce. Again gravity, reduce, acceleration. Correct answer is answer number 1. Correct answer is answer number 1. Here it's a curve, don't forget that. Because as it keeps going down, the velocity will increase. Here v1, here v2, here v3, here v4, here v5, here v6, here v7, here v8. When the velocity is increasing, the induced EMF will also what? Increase. Induced EMF increases, force will increase. Force will increase means acceleration will increase. So deceleration will occur. The rate it changes will reduce. So here deceleration, again straight curve, straight curve, straight curve. That's how it goes. Here it's going to be a straight line. Straight line means it is going with a constant velocity, same force. Here same velocity means same force. Same force means what? Same deceleration. So constant deceleration. Or acceleration is lesser. Positive acceleration is less. So you think when this might occur? This might occur. Loop is falling with constant speed. Constant speed. Constant speed under gravity. So you can't say falling. Well, you can say this with it. Without the word falling, right? They might ask you, when will this occur? Maybe object is going horizontally with a acceleration. So constant acceleration, acceleration reduces. Constant acceleration, acceleration reduces. But your correct answer here is answer number 1. It's a curve. Okay, no? Right. Structured essay. Structured essay. Right. Have a look. So this is a very famous practical. Figure 1 shows a schematic diagram of a properly arranged experiment setup by a student. Determine the focal length of a convex lens. Determine the focal length of a convex lens. In this experiment, the position of the real image of the pin X is found with the help of pin Y. So you are using non-parallax method. Non-parallax method. What is the advantage of having a screen S? So why are we having a screen S? Not to see images. To stop visual obstructions. Visual obstructions from surrounding objects. From surrounding objects. So stop visual obstructions from surrounding objects. That's the main reason. Right. Moving on. Figure 2 shows the field of view with pin Y that the student sees when keeping his eye at point E on the principal axis, observing the real image. Now, if this is the object, you see a real inverted magnified image. So, what you will see here is a real inverted magnified image. So, I'll move it a bit down to draw real inverted magnified image. Real inverted magnified image. Okay, no? Right. Draw the image of X in figure 2. I have one. Right. Then what? If the student moves his eye sideways, we call this lateral direction. The movement of Y and the image of X, what will he see when the image of X is not formed at the position 1? So if it's not formed, there is a relative motion. There is a relative motion between pin Y an image of x. So when you are moving your eye in the lateral direction, if the pin and the image are moving with a relative motion, that means they are not coinciding with each other. They are not coinciding with each other. Right. Next one. The image of x is formed at the position of y. When the image of x is formed at the position of y, no relative motion between image of x and pin y. No relative motion between image of x and py. Write down the relationship object distance u, image distance v, focal length f after applying sign convention to the lens equation. After applying sign convention to the lens equation. So here 1 over v minus 1 over u equals 1 over f. U is going to be positive, v is going to be negative, opposite to direction, focal length is minus. Simplify this, 1 over v plus 1 over u is equal to 1 over f. 1 over f. Right. Then what? A student recorded uv in centimeter and plotted the graph shown. So actually you can keep a ruler and plot this graph here. All the points are there. There you go the graph. There you go the graph. How to determine? Show with properly selecting, determine the focal length. Please name the axes. Please name the axes. Now 1 over v minus 1 over u is equal to 1 over f. Y is equal to minus mx plus c. So your y-axis is 1 over v per centimeter. Please name the axes. If you don't name the axes, you won't get marks. Here 1 over u, 1 over u, 1 over u per centimeter. 1 over u per centimeter. Now your y-intercept will be 1 over f, 0.1. So label the axes done. Label the axes done. This part is done. Determine the focal length. Y-intercept is 0.1. 1 over f. F is equal to 10 centimeters. F is equal to 10 centimeters. Right. Okay. For a certain position of x, virtual image is observed by student. He decides to find the position of the virtual image by using a plane mirror. By drawing figure 1, show how he should place the plane mirror and the pin y and label the plane mirror as a new position y as y dash. I'll draw it here. Screen S is there. Here your convex lens is there. Now what happens is, the observation skill, remember, what happens is, virtual upright magnified image means, you will get an image. This is pin x. You will get an image which is bigger. You will get an image which is bigger like this. Image which is bigger. Screen S. Now when you place your eye here, we have a problem now. Image is seen on top. Image is seen on top. Okay. Image is seen on top. So what you do, you can place a plane mirror here and another object pin there, y dash. So you can't see this, but you can see the top of that. So what will you see through this? Half of it is mirror, half of it is mirror. Top half is lens here. If I look from here, half of it is mirror, top half is lens. Lens is there. And here, bottom part is mirror. Bottom part is mirror only, I will see. Mirror only, I will see. So what will I see? I can see pin y dash. Pin y dash. And also I can see the image here bigger. Image there bigger. That's the image of X. So through the mirror I am seeing the image. This distance, let me take it as X. Images will coincide. Again somewhere here it will coincide. Image of y dash. This and that coinciding means here this gap I'll take it as y. Gap I'll take it as y. So what is your object distance? What is your object distance? Object distance here. Oh, sorry, image distance. Image distance is x minus y. Image distance is x minus y. Object distance, of course, you can find u. Object distance you can find u. So image distance is x minus y. What is x minus y? X is the distance from the pin to the mirror. X is the distance from the pin to the mirror. Y is the distance between the lens and the mirror. Object distance equal image distance. This is the image you see. Image of y dash. Image of y dash. That's the image of X. Image of y dash and image of X, they coincide with each other. No relative motion. For a concave lens or for a virtual object you can do the experiment. For virtual objects you can do the experiment. So what you should need is actually, anyway you get all up in here. Tall image is C. There. Tall image is C. So you can write here. So if I keep a pin X, image of X only is here. Image of X. Keep a pin Y in front of a mirror. Virtual object is seen in mirror. Object distance equal image distance. This is X means this is X. I am drawing it slowly. Gap between the mirror and the lens is Y. So this is X minus Y. Image distance found. Object distance found. You can find the focal length. Okay, no? That is one sentence there. Whenever we find a virtual image using no parallax method, when we find the virtual image using no parallax method, we use a plane mirror. We use a plane mirror. So if you are actually drawing it with symmetricity, these values keep the object. These values keep the pen. Right. Blue. Somewhere here. This is y dash. This is the image of y dash. This is x. That's the image of x. What am I seeing here? Image of y dash, image of x. I move the eye in the lateral direction. Move the eye in the lateral direction. Clear? Move the I in the lateral direction. Move the I in the lateral direction so that there is no relative motion. So from here to here it's x. This is also x. If this is y, x minus y is image distance. Right there. Through the mirror we can see the image of y dash. Through the mirror we can see the image of y dash. And through the lens we can see the image of x. Through the lens we can see the image of x. Image of x. When we move the I in the lateral direction, when we move the I in the lateral direction, there is no relative motion between Ix and Iy dash. There is no relative motion between Ix and Iy dash. There is no relative motion between Ix and Iy dash. So we can find the required distances. Right. Essay question. Have a look. A particle of charge plus q mass m is moving along the positive x direction in a vacuum where the electric field is 0. So here electric field is 0. Particle enters the electric field at x equal 0 with a velocity v. Electric field is directed along the negative x-axis. Describe qualitatively the motion of the particle entering. So what will happen? When the positive charge enters, because of the electric field there will be a force in the opposite direction. So the particle will deaccelerate, come to what? Rest. So there will be a deacceleration. But still there will be a force in the opposite direction. Then what will happen? Particle will deaccelerate, come to rest, then turn back and accelerate outwards. So once it goes out, the force will become 0. Force will become 0 means it travels out with a constant velocity. So you can write that. When Q enters, the electric force will be opposing the motion. It will uniformly deaccelerate. And come to rest. Uniformly deaccelerate and come to rest. Then what happens? Still the force will exist. Still the force will exist. Therefore, it will accelerate. Towards the negative direction, towards negative x. It leaves the field with a velocity v. And keeps moving. with the same velocity. With the same velocity. Okay. So what happens is very simple. Deaccelerate, come to rest, turn back, accelerate, come out, force is 0, traverse with a constant velocity. Traverse with a constant velocity. Right. So basic motion you can see. Right. Okay. Two particles P and Q, each having charge plus Q mass m, start moving at T equal naught in a vacuum simultaneously. V1 is larger than V2, so this travels faster. Right. Okay. If two particles traveling the field-free region obtain an expression for the separation d between the two particles at the instant the faster particle reaches L. So V1 is larger. Time taken by P. So write in words. Time taken by P. Time taken by P is L over V1. Right. Distance traveled by Q. Distance by Q during this time. During this time. Distance is speed into time. Speed into time. Right. Then you can find the separation. What is the separation? P is already here, Q is already there. Separation is L minus V2L divided by V1. Take L out. V2 minus V1. There. Separation can be easily found. Separation can be easily found. So P is here, Q is here. That's V2, V1, L. So the separation is that distance. L minus LV2 over V1. LV2 over V1. Right. Okay. Right. What else? Have a look. At x equal L, okay, two particles enter the uniform electric field E directed along the negative direction, okay. If the electric field is extended from L to L plus H, obtain an expression for the minimum intensity of the electric field required to turn both particles back and make them travel in the negative x direction, right. So what is your logic here? I'll do the question here itself. Right. Now, h distance here, there is an electric field. They want the minimum electric field. What do you mean by minimum? Why minimum? Minimum means, look at the board. Faster particle enters with velocity V1. Slower particle enters at a different time with velocity V2. So faster particle, both have the same charge. Go back, check and see, both have the same charge. Same charge, same mass, right? Same charge, same mass. So higher one will come to the very end and stop. There will be a force acting in that direction on this mass and charge. Slower one will come and stop somewhere else. Shorter distance. Velocity V2 is slower. So minimum occurs when the faster one can reach to the very end. Right there. Minimum electric field will occur when the faster particle can reach to the very end. Can reach to the very end. So F equal ma forward, you have minus EQ, E minimum Q, mass into acceleration A1, A1 is equal to minus E minimum Q over simple M. Okay. V squared equal U squared plus 2AS forward. Final velocity 0, initial V1 squared, 2 times acceleration minus EMQ divided by simple M, distance h. Take it to the other side, simplify it. 2EMQH divided by simple M, V1 squared. H is equal to, sorry, we don't want H, no. We want EM. EM is equal to mv1 squared 2qh. mv1 squared 2qh. Right? Faster particle will stop here, means smaller particle will anyway stop and then accelerate upwards. Basic motion logic. Faster particle will travel a longer distance under the same deaccelerating force. Slower particle will travel a smaller distance under the same deaccelerating force. Short distance. Right. Now consider a situation where E is greater than EM. Now what if the electric field is greater than this? The faster particle will come to the very end? No. If the electric field is greater force, so it will deaccelerate and stop earlier. It will stop earlier, right there. If E is larger than EM, if E is larger than EM, the faster particle will travel a shorter distance than h before coming to rest. Right. Let's draw this. Now E is going to be larger. So velocity v, this flow will stop somewhere here. Force is still acting, mass m, charge t. Obtain the expressions for time Tp and Tq spent inside the field. So this particle will travel here, go here, turn back and come here. What about Q? What about Q? Velocity v2. Q will travel a shorter distance than that. Q will travel a shorter distance, come and go out. So what can you say about the displacement? Displacement 0. S equal ut plus half a t squared forward on t. Going, coming back means displacement 0. v1 times dp. Half deacceleration minus EQ over simple m times Tp square. Simplify this carefully. EQ over 2 simple m Tp square. V1 Tp, Tp is not 0, you cancel off. Tp is 2m V1 divided by EQ. Similarly, you can apply S equals ut plus half a t squared forward acting on Q. Going, coming back means displacement 0. Velocity v2 times tq. Deacceleration is minus eq over m tq square. eq tq squared over 2m v2 times tq. tq cancel off, not 0. tq is 2m v2 divided by eq. So time taken by P and Q inside the field is given. Inside the field is given. Right. Okay. Going, coming back means displacement 0. Going, coming back means displacement 0. Right. Moving up. when the intensity of the electric field is equal to a certain value E naught, both particles P and Q, which have entered at different times due to difference in initial velocity, leave the electric field simultaneously. Write an expression relating E naught to the other relevant parameters. Interesting. Now what are they telling you? These two fellows enter at different times. No? They will leave together. So I'll draw this here. So here they are starting together, P and Q. T equal naught. Here I have a velocity V1, here I have a velocity V2. So if I draw this carefully here, P1 travels some electric field E naught, sorry. It will go here, turn back, come here. This will also enter at a different time, go and come here. When they are coming out, they come together. So total time taken is same. So total time by P equals total time by Q. Write down expression for E naught, right? So time by P is outside here, L divided by V1. Inside, of course, you have found 2m V1 divided by E naught Q. You can substitute E naught. So inside we know the time E, now you put E naught. For there also E naught. Now here LO V2, 2m V2, E naught Q. So time outside is different, time inside is also different. Total time is same. Total time is same. Here is your relationship. Here is your relationship. Right now. Clear? So today we did a thorough discussion, especially the electric field. Some of the questions, because they are electricity, electronics, you all need some additional help. So therefore that was done. Right now. So total time taken will be same. Total time taken will be same. So very simple electric field question. Right. So what have we done so far? Week 5 done. How many MCQs? 5 weeks, 60. 300 MCQs. How many structured essays? 3 times 5, 15 structured essays. How many essays? 3 times 5, 15 essays. You have achieved this, like I always said, upward motion. Upward and onward. Is it clear? So keep working. Week number 6 also do it with the same enthusiasm. Now some of you all in the beginning, everybody now, some of you all again you are lacking. Remember, when you are into this, you make sure you somehow do it. Don't wait, later I will look at this, later I slowly do and look, there won't be a time again. Now is the time, do and finish it. So otherwise later the added pressure of all the 3 subjects will increase. Now itself, so you do and finish it off. Is it clear? But then again, only about 5% will do what we tell. Clear? But that 5% will do very well. And the ones who want to do somehow pass the exam, make sure at least now, in the final, already now 5 weeks gone. That means we have 19 more weeks for exam. 19 to 18 weeks for exam. At least now listen to what we tell and do. Otherwise what happens is, there is no turning back. The ones who are listening, who are following orders, who are preparing accordingly, will go forward. The others sadly will fall off. Which sadly, even if you don't follow, it will happen to you. So make sure you don't give up, be at it, because always the prize is for the ones who don't give up, who hang and wait on achieving your goals. Right. See you all next week with week number 6 work. Stay home, keep working, take care.